Hello everyone, we're the Group 9 and I'm Miss Vika Daliada.
I'm Leonard Brendan Liputon. I'm Radio P. Santos.
And we're here to report our topic about fossils.
Fossils can be placed into different categories. The categories are molds, casts, petrified fossils, carbon films, trace fossils, and preserved remains. A mold fossil is a hollow area in sediment in the shape of an organism or part of an organism. Molds form when the organism is buried in sediment. A trick to remember this is that because a mold is indented, it can hold water. So a mold can hold. Cast fossils are solid copies of a shape of an organism. Casts are made from molds. Therefore, the cast can fit into the molds. The first image shows a mold on the left and a cast on the right. The second image shows a cast of a plant. The third image shows a mold of a starfish. And the fourth image shows a mold on the left and a cast on the right. Petrified fossils are fossils in which minerals replace all or part of an organism. Eventually, only the minerals are left behind and the minerals look like the organism. For example, many people think that fossils of dinosaurs are actual dinosaur bones. These fossils are actually petrified remains. The dinosaur bones were replaced by minerals. The first image is a petrified tooth. The top right image is a petrified dinosaur fossil. The bottom two images show petrified wood. The Petrified Forest National Park is located in Arizona. Carbon films are fossils that consist of a very thin coating of carbon on rock. When sediment buries an organism, some gases escape from the sediment, leaving behind carbon. After a very long period of time, only a thin film of carbon remains. The images on the right and top left are carbon films of plants. The image on the bottom left is a carbon film of an insect. Trace fossils are fossils that provide evidence of the activities of ancient organisms. Trace fossils are also other types of fossils. For an example, an indent of a footprint would be a mold and a trace fossil. Other examples include fossilized trails and burrows. These three fossils show footprints. They are trace fossils, but they are also molds. These two fossils show trail marks or burrows. Preserved remains is the preservation of the actual organism. This happens when an organism is trapped in tar, tree resin, which is later called amber, or gets frozen. The top three images show organisms preserved in amber. The middle image is from the movie Jurassic Park. In the movie, they used the blood from a mosquito trapped in amber to get dinosaur DNA. The bottom left image shows insects fossilized in tar. The bottom right image shows a frozen woolly mammoth.
I'm going to discuss about fossils. Fossils are preserved remains of organisms. Example of this is Glossopteris. I'm going to discuss about fossils. Fossils are preserved remains of an organisms. Example of this is Glossopteris. So what is Glossopteris? A Glossopteris is an extinct plant were found in 250 million years ago. Glossopteris was used by Albert Wegener in his theory about continental drift because he realized that there will be no identity. Another example of fossils are Liscrosus. Mesosaurus. These are both freshwater animals. Liscrosus is also known as shovel reptile. This animal is an herbivore with a stout build like a pig. It is approximated that it grew up to 1 meter in length and it was dominant on land during early Triassic period. Another type of freshwater reptile is the Mesosaurus. So what is Mesosaurus? Mesosaurus is an extinct genus of reptile came from the earlier Permian of South.
So guys, I'm here to report about index fossils. So, what is index fossils? Index fossils, also known as guide fossil, indicator fossil, or zone fossils. Index fossils are fossils used to define and identify the geological period or faunal stages. They work on premise that although different sediment may look different depending on the conditions under which they were laid. They may include the remains of the same species of the fossils. So that is what is the introduction about the index fossils.
Hello guys, so this is the example of the index fossil, the cyanobacteria. Hello guys, so this is the example of the index fossil, the cyanobacteria. What is cyanobacteria? The cyanobacteria have an extensive fossil record. The oldest known fossil, in fact, are the cyanobacteria from the Archean rocks of the Western Australia dated 3.5 billion years ago. This may be somewhat surprising because the oldest rocks are only little older. Example of the index fossils, the trilobites and the ammonoid. Ammonoid and the trilobites are one of the two extinct marine species that lived 1.2 billion years ago. They are used to determine the age of the geological time that we are in now.
So my topic is all about fossil fuels. So
Ano na eh? Ano ba yun eh? Wait lang. One. Ay.
So my topic is all about fossil fuel. So what is fossil fuel? Fossil fuel is essentially remains of ancient organisms, predominantly plants and bacteria. So this is organic resultant from ancient forests and swamps that existed on Earth from 100 million to 500 million years ago. Following changes in Earth climate and the geology, a portion of the material was struck below The surface under multiple layers of sediments and rocks. Fossil fuels are resultant of burned carbon over the last. So we have three categories of fossil fuel. First is coal. Second is petroleum. And the third one is the natural gas. So coal. So we have three categories of fossil fuel. First is coal. Second is petroleum. And the third one is the natural gas. So coal. So coal has been used to power steamships and railroads, engines, and provide heat for steel production since 18th time of category of fossil fuel is the petroleum. Time of category of fossil fuel is the petroleum. Petroleum is described as a thick, viscous, and flammable black liquid that has been used for lighting since the ancient times. Over 40% of our total energy consumed is derived from petroleum products such as gasoline fuel, propane gas, and domestic cooking and heating fuels. So the third category of fossil fuel is natural gas. So the third category of fossil fuel is natural gas. It can be found in locations where petroleum is extracted. Natural gas produces less air pollution. Most combustion engines can be modified to use natural gas. It is one of the fastest growing sources of the worldwide.
Planet Earth, home to over 6.5 billion human beings. Over the last 100 years, our species' appetite for energy has increased staggeringly. Exciting new technologies, funky gadgets, and amazing machines are just some of the things which add to the energy we demand every day. But where do we get this energy? Most of the energy found on our planet begins its journey at the Sun. As the Sun shines down on the Earth, some of this energy is captured by green plants and stored. When these plants are eaten, some of this energy is passed on, and if that animal is eaten, it's passed on again. This is a simple food chain, providing the energy our bodies need. However, getting hold of this energy so we can use it to power technologies and machines can be tricky. We don't usually use the energy stored inside plants and animals alive today, but we do use energy stored in ancient animals and plants from the past. To find this energy, we don't need to go back in time, we just need to dig deep into the upper layer of our planet, the crust. If we dig in the right spot, we can find these ancient remains. But they don't look like animals or plants anymore. They have transformed into coal, or gas, or oil. We call these fossil fuels, and we can burn them to make the energy we need. But hold on, let's rewind for a minute. There's a few mysteries to be solved here. How do these ancient animals and plants change to become solid coal, liquid oil, or even gas? Also, why are they found deep underground? Why not lying about on the surface? It certainly would make them much easier to find. Part of the answer to these questions is locked up in the time it takes for them to change. In fact, the true age of many of these animals and plants is older than the pyramids, older than the last ice age, and in some cases older than the dinosaurs. Let's look really closely and find out exactly what happens to make them change from a living thing millions of years ago to a fossil fuel today. The first thing to realize is that not all ancient animals and plants become fossil fuels. In fact, there are 4 different things that must happen to an ancient living thing in order for them to transform into a fossil fuel. We call these conditions, so let's have a look at them. Let's examine them one at a time and find out what they mean, beginning with this condition, the need for a saturated environment. But what does saturated mean? Imagine a sponge. Dip it in a sink, and all of its tiny holes fill up with water. When the sponge cannot hold any more, we say it's saturated. A perfect example of a saturated environment is a swamp. This time, let's have a look at the need for an anaerobic environment. But what does anaerobic mean? Anaerobic sounds like a complicated word, but it just means that there is no oxygen around. Now, lots of living things, including you and me, need oxygen to survive, so we live in places where there's lots of it. We call this an aerobic environment. However, some living things, like certain types of bacteria, like to live where there is no oxygen. This is called an anaerobic environment. A great example of an anaerobic environment is in a swamp. Up next, let's have a look at the need for high pressure. But what really is pressure? Pressure is a force pushing down on or against something. A good example of a place with really high pressure is deep underground, where there's lots of rock pressing down. The more rock, the more weight, and so the more pressure. And finally, the need for high temperature. So, what exactly is temperature? Temperature is the measure of how hot or cold a place is. Now, we all know that the sun can make places hot on the Earth, but it's also very hot underground beneath the Earth's surface. This is because the Earth produces its own heat. An example of a really hot place is in deep mines. Okay, let's recap. This means for our ancient living things to turn into fossil fuels, they need a saturated environment, anaerobic conditions, lots of pressure, and high temperatures. Let's watch the whole story now, from an ancient plant to a lump of coal. Tropical areas provide the ideal conditions for plant growth. Millions of years before the dinosaurs walked the earth, the land was covered in early types of plants, mainly ferns. In tropical areas, these ferns were huge, gigantic tree ferns. At this time in the Earth's history, lots of changes were occurring across the planet. These changes caused sea levels to rise and flood the land, saturating the environment. As the water levels rose, small particles of soil and sediments were washed in. These gradually began to settle out to form a layer on the bottom. These changes transformed the area into a swamp, and over time it became more and more anaerobic. Without oxygen, the plants and trees died, toppled over in layers, and were then covered with water. Beneath the surface, in these anaerobic conditions, the plants, however, did not fully rot away, as oxygen is needed for things to properly decay. Gradually, layers of this plant material built up, and then sediments continued to wash in, forming another layer on top, a bit like a sandwich. When the water levels eventually dropped, these sandwich layers left behind were rich in nutrients, ideal conditions for new plants to grow. These plants then grew big over many years, and then the whole process began again. In fact, over millions of years, this process repeated over and over, like a cycle. So, in the formation of coal, ancient forests became flooded, and the rising water brought lots of sediments. These swampy conditions then became anaerobic and caused the trees in the forest to die. Layers of dead trees began to build up, and they were covered by sediments washed in with the rising water. In these anaerobic conditions, plants and trees could not fully rot. When water levels dropped again, layers of compacted dead plants, buried under a layer of sediment, were left behind, creating the perfect environment for new plants to grow. This process repeated over millions of years, and each time creating more sandwich-like layers of plants and sediments. As more and more layers piled up, both the temperature and pressure increased, pushing, squeezing, and heating the plant material to form coal. This process created the layers of coal that we see today when we dig underground in parts of Scotland.
This is the end of our report. Thank you for listening in our video tutorial. Here again, I am Rhea Shimpi Santos.
And dahil sa ito na yung tendang ng motor,
And I'm Miss Vika Nagada.
Here, thank you.